I'm joined today by Alyssa Ross of Metafold and Rui Aguiar, if I said that right, of
That is correct.
Cosmon. Very exciting startups in the engineering and simulation space, and I'm really happy to have you both. Alyssa, do you want to start telling us about yourself and about Metafold?
Yeah, absolutely. First of all, thank you for the invitation. It's certainly a pleasure to be here. So I'm the CEO of Metafold, also a mathematician by background, so I have a PhD in geometry. And at Metafold, we are really all about geometry, and in particular, converting geometry into information that is helpful for manufacturers, that is meaningful for critical decisions in manufacturing. And I'm super excited to get into the intersection of all these topics with AI, but I'll just give a brief preview that our company is really based on, I won't call it traditional, but I will say kind of true mathematical analysis of shapes. And there's a
Mm,
very interesting interface between that and what's going on, of course, right now in AI, which we'll surely get into.
that's awesome. Tell us a little bit about Rui and Cosmon.
Yeah, so my name is Rui. I'm founder and CEO of Cosmon. My background, double degrees in hardware engineering, systems engineering, grad degree in artificial intelligence. What we do is at Cosmon is we build agentic tooling across the design to production life cycles. So whenever you build something, there's 50,000 things you got to do across CAD tooling, simulation tooling, PLM tooling. We build agents to make those processes better, faster, easier, more streamlined for organizations. Specifically, we focus a lot on sort of more novel deep learning methods, agentic architectures, sort of like model development, performance across domain-specific tasks in engineering that are hyper specialized without having to use a lot of IP or anything else like that that can be kind of bolted on out of the box. And we especially excel in specific design and simulation use cases as our sort of initial adopter.
Awesome. And it's kind of we're a bit of international today too, right? Because I'm coming in from Paris. So Rui, you're in San Francisco, and Elisa, you're up in Canada. So
Correct?
that's kind of a lot of fun. Um, that's exciting. So like I usually start the an icebreaker question around when the open AI moment happened, when the moment pivoted around LLMs. Alyssa, were you like super bullish? Like, oh my God, this is gonna change everything, or were you more wait and see, a little more skeptical about, how it was gonna change how we do engineering and how we do manufacturing?
Yeah, it's an interesting question. I think, like so many people, I had this reaction to it where it feels just like simply magical at first. The first encounter with an LLM was, kind of mind-boggling. But I think for me, always, I come back to how does this work for geometry? How does this work for 3D
Mm,
data? So this has been the central question in our analysis of AI, and the fundamental truth is that what's happened over the last few years in terms of LLMs and text is very, very different from progress on 3D data
right.
and geometry. And so there's no analogous model for 3D geometry. Lots of reasons for that. 3D geometry is just so much more complex, more heterogeneous. There are no data sets like the huge amount of text that we have. And just comparing geometry to text, text is so simple. Even two-dimensional images are far, far more simple than the three-dimensional case. So I think my reaction to the language models was kind of distinct from my reaction to anything in 3D. And I think what has been kind of maybe confusing for the market is that people expect that you can do the same things for
Mm,
geometry, for engineering, for anything you want, actually, as what is happening with the language models. And this is really not true. We have some progress, we have sophisticated things happening in other kinds of data, but it's not the same as for text. So I think that's kind of my key reaction. Like, this is not going to transform engineering the way that people might at first think it will.
mm. Interesting take. I like that. How about for you, Rui?
Yeah, so I come a little bit more from the sort of traditional AI world, living in San Francisco and so on. So actually, my first interaction with GPT 3.5, I wasn't really that impressed. I mean, I was like, okay, you guys have scaled up, GPT 2, GPT 3 has been coming around since 2018. Like, really, I think what the actual, and I mean, there was some innovation around of course, the training data and the corpus and the construction of these models. But the real innovation here, I actually think, was on user experience land. I think it was in the ability to really have this thing that you could interact with in like an easy, accessible way that was simple, that was sort of allowed it to take off from a viral perspective. I think it definitely wasn't clear as of early 2023 or whenever, even 2024, sort of the industrial and corporate use cases. As chatbot is like, okay, there's pretty good consumer product at this point in time. A lot of the kind of core use cases and stuff like Anthropic haven't really been kind of bought out. I don't even think coding was even considered at this point in time as a major use case. And so, it's going to be interesting to see how these things evolve. I think that in various domains, you get various spectrums of autonomy and sort of agentification, or whatever you would like to call it, across engineering, across legal, across doctors, across coding. You have some that take off. You have some that take off faster than others. Obviously, coding has basically completely gotten turned around in the past 3 years, where now the entire field has been basically just taken over by agents.
We'll be
You
talking
have
about that in a
slower
minute.
yeah, you have slower adoption on sort of the middle grounds, legal, doctors, where you can still create a lot of value in building out these things and then deploying it across these. Engineering is a little bit of a weird one. Engineering is something that I think we've seen basically no penetration into so far, again, for a variety of reasons. Technical being some of them, probably IP and security being some of them, skepticism maybe being another one of them, having the right use cases. What we strive to do at Cosmon is we try to strive to strike a balance, right? You get a spectrum on agentic development, you get a spectrum on agentic design, all the way from like, there are a lot of companies today that are like zero shot me like a car. And I'm like, this is completely worthless. Like, no one is ever going to go and trust this thing, right? All the way back down to like, more simple things of just like, hey, help maybe review my drawing or help do this sort of 2D work or something else. And really, like when you think about building out a useful agent for an engineer, it ends up kind of somewhere in the middle here, and that's still being defined. I think that's personally very exciting. I think that a lot of people don't know what's possible. Like there's a lot of things we're trying out internally. But this is kind of where I see the state of the art today for the field.
But it's yeah. It made me, when you mentioned the text interface, it's kind of funny too. Right, to think that Google changed the world by just giving us a line in the middle of the screen, and then we spent 20 years building all this stuff all over the place, and then ChatGPT changed the world by putting a line in the middle of the screen. All this other UI stuff is kind of crazy that the one line is the thing. So, and you alluded to the changes in R&D. I wanted to talk a bit about that, like how at Metafold and at Cosmon, you guys are using AI in coding or in program development. Certainly, probably your PRDs are probably already done more or less by AI. Like a question I've came up with a week or two ago is, when are we going to start having agents showing up for the Scrum meetings instead of in place of or in addition to the people? So, Rui, why don't you pick this one first? How are you using Cosmon? How are you using AI, and whether it's Claude Code or anti-gravity or whatever? Probably not lovable,
Not so much.
but how are you using it to build Cosmon?
Yeah, so when you think about AI for software, the real cost in software is not actually like the lovables of the world, the zero shotting your one out. It's like maintenance, it's technical debt, it's recurring costs and use cases. So we try to really deploy it for like the cost centers of the business. This is, I think, why something like a Claude Code is so valuable. So we use that pretty extensively across the engineering team. I think pretty much everyone's on it. I don't think anyone's on anti-gravity. In addition to that, we use some for customer support, answering use cases. And then we also use some for just like drafting, like slide generation, more classical use cases within the org. So engineering, customer success, outbound marketing use cases, I think are mainly where we're seeing adoption on it right now in the company.
Okay, but it has okay. I'll let Lisa answer first, and then I've got a follow up.
Yeah, no, I would say at Metafold we mirror that fairly closely. I think one of the most useful things for us has been more on the productivity side, especially when it comes to creating just like documentation, and so on. I think though on a engineering side, I mean, not to get into how we do that, but it definitely leveraged more sparingly there because of the nature of the work we are actually doing, like on geometry. There's just it is not as effective in that area.
Because it's not text based; it's geometry based.
Yeah, exactly.
but are you seeing that? Well, so you guys aren't okay, because I was wondering if how AI might be changing the model. Like up to now, we've been developing with the V, or we've been doing agile, right? And it seems to me talking to some other startups that those models are actually sort of merging in a way because the interactions between developers are so much faster, and plus, developers with an agent next to them is sort of going faster than maybe a team of developers because you can pop up in UI, but then you get a bit in other words, it's sort of an 80-20 thing. You can get 80% of the way to something that's working, and that other 20% will take you 80% of the time to get right, all the corner cases and stuff like that. And it seems that that's changing a bit, or that could have a big impact on agile and or waterfall and or right. I just wonder what your thoughts are on that, at least.
So
Or
yeah, I think what happens is you get a team of editors instead of a team of writers, which is kind of interesting. Where beforehand you have your coders and you have your development team, and they're constantly just like writing, churning out code, running these agile methods, and then you get something like Claude Code or these multi-agent system spin up, or some of these agentic software engineering. And what happens is the engineer ends up becoming like an orchestrator and like moving to a higher level of sort of complexity, where they're like managing these agents, like working through these kind of like high level problems. And then basically I guess that's what you mean by, okay, then this becomes a team because it's one person and they're coordinating 5 agents, and one's working on the front end, one's working on the back end, one's doing your database migration, one's doing your Scrum meeting. I don't know if that actually changes the model. Like from what we've seen, like Agile still works okay. It's just a question of like, okay, now you get way fewer people, like you're coordinating higher leverage work and your cycles are faster, but you still have your like, ticketing boards, you still have some of your Scrum meetings. It's just like a faster iteration cycle. You're getting, 2x, 3x the amount of work done in the same amount of time. The processes are still okay though, because like you have external stakeholders like customers you got to work with, project management, and there does still need to be a way to like collaborate between these cross-functional teams.
Yeah,
your
I agree
experience?
with this. No, I agree. I don't think it's like fundamentally changed the way engineering and code is being written. Like not in the way you're describing, like the agile versus waterfall. It hasn't meaningfully changed that, at least on our side.
Okay. The so in Cosmon and in Metafold, how does the user encounter AI when they're using the tool? Is it part of the UI or the philosophy, part of maybe the trained models underneath the covers? I mean, how is AI integrated into the product as is?
Bree, you want to start?
Yeah, I could talk about this. So we're AI native. We're basically the entire thing is AI, like end to end, for whatever that means. But really, it's really like it's immediate. A lot of we're very similar to like a Claude Code for engineering, or a Cursor for that works with engineering software. This is something where like we kind of view ourselves as the AI bar for hardware engineering or engineering use cases. So generally you're interacting with it whenever you want to use the product. It's like an AI native interaction. Obviously there are other things here that are important, like you're running a human in the loop process. There are like different processes in place where you're interacting with like a design software, a simulation software, and then you're interacting back into Cosmon. But generally what happens with us is we try to keep things, I believe that all great products are simple. We try to keep things as simple as possible. We put up something that we try to hope can work for engineering processes. Can get a lot of ways we do that: training on engineering data, processes, picking the right use cases that AI can work with. You can interface with it. We try to get at least 80% of the way on a lot of tasks that aren't like incredibly difficult for engineers, automating away a lot of that work, getting a lot of that work done more easily for the engineer and the engineering team, and then speeding up that kind of design to production lifecycle. So back to your question, the whole thing is kind of, AI, it is an AI native company. The entire thing is AI. We have a bunch of deep learning researchers on staff. Like, so when you're interacting with the product, you're interacting with an agent, ideally, basically as close to 100% of the time as possible when you're driving your engineering work.
Interesting. I suppose it's a bit different at Metafold.
Yeah, so this is where I think Rui and I completely diverge. That our product is not an AI product at all, right? So our product is really a geometry analysis product. But where it has this intersection is that, and it kind of comes to the title of this episode, I suppose, is about infrastructure. So we are
Mm-hmm.
one of the challenges of 3D geometry is that the representation of that 3D geometry comes in all different forms. And if you want to do meaningful learning on this, you really need a unified way of interacting with the geometry. So this is something we have developed, a way of both representing geometry and converting it into effectively a feature vector that you can use as the input to a machine learning model. So for us, if you're interacting with AI in the Metafold universe, you're probably running like a fairly vanilla machine learning model on top of our geometry representation. So maybe you have a large corpus of 3D models. You're trying to understand, groups of similar geometries within that data set. This is something you can get by running them through Metafold, getting the feature vector, and then doing some learning on top of that. So really, AI and machine learning is applied on the outputs of Metafold, and we become the kind of infrastructure for converting 3D geometry into something you can learn from.
And when you said the different formats, you're talking about parametric versus implicit versus nerves versus all these
Exactly.
other those kinds
Yeah.
of things.
Well, and critically, most of the time with 3D geometry, there's some discretization that happens when you simply represent 3D geometry on a computer. So you're probably talking
Mm.
about a whole bunch of triangles that represent the surface of the model. And
Rasterization,
then,
right?
exactly. And then you may end up, if you're trying to just run some kind of learning algorithm there, you may end up learning more about the representation than you do about the intrinsic shape
The actual
itself. And this
geometry.
is this is critical. Like it doesn't matter, it should not matter how you represent the shape. What matters is the shape itself. And this is with engineering, like the true challenge in engineering is that the details matter so much. Sharp edges, features, holes, like it all matters, and it all has this kind of latent expertise embedded into it that is very difficult to learn.
That makes me want to ask, like, um, so you guys both have to interact with the legacy systems, or the systems that have been there forever, the Siemens, PTC, DS universes. So how do you guys fit into those workflows so that the user is doesn't have to interrupt his work and stuff like that? How does that actually work so that it's inside the workflow of the engineer, Alyssa?
Yeah, I mean, Uh, I think you're right. We have to interface with existing tools, and so this is why our offering is fundamentally API based. It just means it's extremely flexible. We can be inside existing tools. We can create applications, and here's where AI is amazing. You can spin up a web app very very easily, things like this. So. I think for us, it's all about flexibility, treating different file formats, different representations, but bringing them into the Metafold representation and leveraging that to get the information that people are looking for, but then also being embedded into existing tool chains and workflows so that we're not like adding a thing and adding a step.
But then when you're done, does it get pushed back into a system of record, whatever you did with Metafold?
Yeah, most likely. I mean, it's very case by case, but yes, exactly. Like we try to come back into the format that people are expecting.
Whereas, Rui, you're more acting on top of between the systems of engagement and the systems of record, right? Because you're working
Yeah.
with the CAD guys and you're also having to directly interface with the system of record, right?
Yeah, so we kind of model ourselves off of a lot of the sort of more common agentic tools that are workflow orchestrators. So again, it's not necessarily like you're bolting onto something in and out. Very similar to probably Alyssa here. It's API based. You're interfacing in and out. You're working with these tools. You're exporting things. You're importing things in place. With us, like yeah, we're like workflow orchestration. So we have to connect to the tools because that's like how you do engineering, right? Like you're not going to do engineering with your Creo or your SolidWorks or your Ansys or something like that. Like that's just not going to happen. So we kind of have to do that. The challenge for us becomes, maybe similarly, like how do you think about interfaces and boundaries here? Because, it's not text based. Like there's metadata, there's information out of these systems. Like, for example, we have a customer who we're talking to or who we're working with, and they're like, well, I want to use this across specifically Ansys and SolidWorks, right? but they're like, what can I do? Like, how can I use an agent to take the output of a simulation and then use that to go modify a geometry, or think about how I can perform geometry modification upstream or downstream of the results and perform these changes. And so when you think about integrating into existing tooling, it's not just plugging into one tool or plugging into another tool. It's like, how can you take the context out of both of these types of tools, understand like how one can kind of implicitly reference the other, maybe with help from the engineer of like, hey, here's what I'm going to look at. Here's kind of a judgment call or perspective in terms of how to think about this, and then kind of work across both of these. And then when you think about an agent, when you think about development, it then gets really hairy of like, well, how do I even think about the boundaries between these two? When do I know how to switch? How do you build that into a product line? And so ultimately, I think it becomes like, number one, we want to be basically from an interface perspective, you want to be as seamless as possible on top of an engineering workflow, like as an orchestration tool. Number two, you have to coordinate like multiple forms of information. And that's still like an open question as to like how to actually perform this, which we're trying to kind of solve. And then number three, you have kind of a user experience question here of like, even if you're working on top of these, even if you're bolting on top of these, how do you move across tools? How do you move across orchestration in like a reasonable way that is like not super error prone, or that an engineer is kind of amenable to? Maybe it's human in the loop, maybe it's some other things, but that's how we kind of think about running on top of it.
Interesting. I usually throw a question about this time about for the next generation of engineers, what the kinds of things they could be focusing on, but also makes me want to think about how engineering itself is going to be evolving more towards prompting than engineering, but with an understanding of the physics, right? So it's kind of interesting the way that it's almost impossible to even look 3 or 4 years down the road because the things are just changing so fast. But it seems to me that well, what do you guys think are the critical skills that the kids that are in school and looking at the job market and saying, "Oh my God, I might as well go to theater because it'll be just as easy to get a job from an AI in theater than it will be in engineering," right? What kind of advice would you give to them, Elisa?
Oh man, that's such a tricky one, and I'm reluctant to go on record giving any advice here.
We'll have to
Um,
scrub it after.
yeah, exactly. But I mean, like something actually in what you just said, Rui, was interesting. Like you have these agents, and they can they can kind of not automate. They can do a lot of the work of the engineers that previously people went to school to do this. But you also said something, which is that like at some point in that flow, like you need to hop out, and the engineer needs to like bring their expertise and come back in and direct, right? And so I maybe I don't know, like I still think that a kind of classical training and an understanding, a true understanding of the physics and the engineering principles that are at work is so important, because this is not like these agents, like they don't understand the 3D world that we are sitting in right now. They don't have like the understanding of a child even about the 3D world. So we can't outsource our engineering to them. Like we need to maintain the integrity of the field. I'm really curious to hear what you're going to say, Roy.
Yeah, so look, I mean, I think like it's actually, I generally agree with this. I would say, like, even in software, like, I wouldn't hire someone who just knows how to use an agent. Like, you need to first principles understand, like, why you're coding something or building something out. I don't really think that ever goes away. This is probably especially true in hardware where you have, like, way more expensive costs down the line than, like, if you ship a broken website or something. And even for software, so, I mean, like, I've had interviews where people come out of college and talk to me and they're like, yeah, I know everything. Like I just have an LLM feed it to me, and that's how I do my job. And I'm like, this is not. I don't think this is going to work out. I'm sorry. Maybe you can go somewhere else with respects knowing everything. But I think similarly, like again, it's a spectrum. I think that it is going to be important to be able to learn and understand how to use agents for different types of workflows. Not everything in engineering is 3D geometry, just like not everything in software is coding. And I think like agents are going to be useful for different things across these, PRM specifications, readouts, like, maybe some basic analysis, interpretation, these types of things, even modifications. But regardless, it doesn't really matter, because at the end of the day, like if you can't ground the thing in like a first principles understanding of physics and a first principles understanding of engineering, it's way too risky to ship a product or build a product out doing that, because you're just way too prone to make mistakes. So I'd actually, maybe in a disappointing way, because it's less controversial, I'd agree a lot with what Alyssa is saying here. Sorry for the podcast listeners, but I would say that like first principles understanding is still incredibly important. It is still incredibly important in stuff like software. you need to understand this. You need to be sort of like formally trained and really like thinking through logically, like from a first principles perspective, like even if you're using an agent, is what this agent's saying actually right? Like these things are stochastic machines. Like they are pretty good a lot of the time at a lot of things, but they are not 100%, and they will never be 100%. And so you're always going to need that grounding. I think human in the loop is always going to be super important. I would say that like from an educational perspective, keep that in mind. Keep that like human in the loop is going to be really important, and like you're going to need to understand all this stuff, and engineering is not going to go away. But also like try to educate yourself with newer technologies that are coming out. Understand that this field is evolving incredibly rapidly. Understand that like look, what's possible today. There may be things in 5 years that are possible now as you're finishing a degree up, if you're starting college or something like that now, that you didn't think were possible when starting out. So I would say, keep it as sort of a hybrid, flexible standard. Don't neglect the kind of classical principles here, but also understand how to use AI, understand where it might be useful, understand where the limitations are. Try to incorporate it where you can in a workflow, and try to stay on top of the developments in the field.
Would you guys feel that with the fact that these tools are getting somewhat easier to use and making it more accessible to more people, that the engineer of the future will be forced to be much more multidisciplined than he or she is today? Because today you can just live your whole life as a mechanical engineer just doing design. But I think tomorrow you're going to have to know a little simulation. You have to know a little bit of manufacturing. You have to know what a milling machine is and whether that's actually you can get the miller into it. Or you're going to have to make a decision that no, that's going to be additive, and then I'm going to use generative design to do that. Don't you guys do you agree with me that there's going to be some modifications to wave engineering where you're not going to be able to just say I'm really good at this one thing, that you're going to probably have to say I'm really good at these 3 or 4 things, or maybe I'm
I,
way off.
I would say like you see a similar dynamic to this. Again, I keep having to do this, but software is like the one field that's actually been disrupted significantly by agents. So I'm kind of extrapolating into like, okay, this is probably what's going to happen to these other fields over the next decade or whatever. I would say like you see kind of two forces at play here. You see like upskilling and you see democratization when you like interface with an AI. Like the first thing that AI and agents and stuff are really good at is, number one, you can democratize access to a lot of things here. So there's this company called Flux. They do like AI for PCB design use cases, and like what's really interesting about them is their baseline customer is actually not an electrical engineer or like a designer. It's someone who's like a mechanical engineer who like wants to break into these things, but like doesn't really know how to kind of develop or can't get access to the data and wants to just spin stuff up and test it. So I think to some extent, like there may be like there may be sort of a rising tide across all things here where it's like, hey, now this can give you a baseline understanding of simulation, of how to think about design, of PLM, of something like that, right? And that'll just naturally come with an engineer. That may not even be something you're forced to do. It's something you just get if you use these tools well enough, and they can integrate well and so on. And then the second point is like, I do think probably this is like an interesting question. Like the question of like, what is the baseline that matters become interesting, because I think in software, what you see is like, the new grad job market, or the sort of like less experienced job market, gets contracted significantly because you can get a lot more done with like a more experienced person who kind of knows this stuff. Now, hardware engineering and mechanical engineering is obviously kind of a lot broader in some ways than just writing code. You have to run through a bunch of different systems. So there may still be some use in specialization, but I do wonder if like, someone who is more experienced, who has used these things a bit and then can get up leveled immediately with like an agentic tool or something like that, could be more productive and could cause, hey, we can just get one person to do a lot here. Again, because there are much more limitations in engineering and software with AI than there are with, something like coding, where it's just one-shotting the thing end to end. That probably doesn't happen at dramatic of a scale, but maybe you see some kind of like compression forces like that in action. We'll have to see.
Alyssa, when do you think we'll see the OpenAI moment for engineering then? When will geometry be able to have its own model, and there'll be like the OpenAI moment? Do you think it'll be in the next couple of years, or you think this is decades ahead?
Yeah, no, I wouldn't make that kind of prediction. I think like I agree with what Rui has said. In fact, that like obviously not all engineering is 3D, but 3D is a big part of engineering, and there's huge challenges here. Like we simply do not have the kind of data that you would require to have an OpenAI moment for 3D geometry, in my view. So yeah, not going to make that prediction here.
Well, then let's just think about the fact that we've gone from 2022, 2023, with the advent of OpenAI, we went through the MCP period, and then now we've hit whatever the hell that Moltbook OpenClaw thing was. Um, are you guys as bullish or skeptical as you were in 2022, 2023? And where do you think it's going? What do any ideas on where we end up? Ooh, there's two of you now, Rui, for some reason. Um,
Yeah, my computer just crashed. I don't know why. Sorry about that. Like it just.
so like, what do you guys think is coming next?
Yeah, I mean, I'll say something like super obvious, which is that it's very difficult to tell what is going on. So there's huge amounts of capital flowing into this industry
Yeah.
that are, absolutely affecting public perception of what's going on, and then also like perception of what's going on. So I think it's very difficult to actually understand. And maybe something we'll come to is like the actual adoption and the actual digital maturity of organizations who might be the people using these tools, because I still think that that's a ways off. So yeah, hard to tell what's going on.
So you're still a bit skeptical, basically.
Well, yes, I am like I am very skeptical. I mean, I am not skeptical that AI is a powerful tool and incredibly disruptive. This is, I don't think, under question.
A sane
But
person could say otherwise.
yeah, no, I think this is very true. But I think like where it is going to be extremely disruptive is still unclear, and I don't see massive disruption coming in engineering or manufacturing. Like we're in manufacturing, so in manufacturing, like people are producing physical things. There's only so much that can be disrupted there, in my view.
Are you a skeptical, Rui, or a bit more
I
optimistic?
think adoption curves. Oh, also, is there an echo? I don't know if I'm in this twice now. I hope not. But okay,
No,
good.
you're good. You're good.
Yeah, my browser crashed. Sorry about that. But look, I think the adoption curves will definitely be slower on a lot of things here, and I think will be, like organizations will not adopt even if the technology is capable, which obviously there are limitations for engineering in the first place. Like organizations will not adopt for years afterwards for a variety of reasons: data security, IP, readiness, skepticism, process training, and so on. And I think this will probably be one of the slower moving fields to adoption. This, yeah, as Alyssa said here, I think manufacturing is especially hard. Like the less you move out of conceptual, where like you're going, and the more you move into like physical manufacturing, that is really difficult to kind of displace. And I would probably agree with like, look, that this is going to take a while. And even for something like what we're doing, it is likely to take at least years of adoption into these larger organizations, even if the technology is working in the first place for some of these types of workflows. I would say, like, that said, there are large pushes by these companies to adopt AI in different forms, in software, in customer success, sometimes in engineering, sometimes in coding, sometimes in these other use cases. And we'll probably know in a few years anyway, from a shakeout perspective, of how this is going to work. I predict that like there will be a large push for this. It will be successful in some places. It will be less successful in other places. The market will kind of naturally figure out like, okay, here's like specific use cases where AI is good for. Here's where it's not. I do think this is a question of at least a few years, not like a few months or next year, or even in 2 years. But I do think that like generally, like markets are not that inefficient. Like there's a lot of capital going into AI, as we've said, right? Like there's a lot of experiments being run. Some of these will shake out. Some of these things will work. It's really about, the ability of the company to figure out like where there's true demand, what's kind of at the edge of like the feature complete set of things that are useful to an engineer that are also technically possible, delivering that to an organization, and then seeing kind of tangible business ROI from there. It's probably where you'll see adoption. I think everything else may struggle.
Um, so the other thing I want to talk about is digital transformation in general. And when I look at digital maturity of companies, I think of like the least mature ones still using email and as collaboration tool, and Excel for almost everything else. And I'm thinking the high end, like I would give that a 1, and a 5 would be fully agentic autonomous digital twins. And I don't think anybody's there, and I think it'll be a while before we're there. Um, so first question would be like the customers where you guys are already using Metafold and they're already using Cosmon. Do you think are they at between 1 and 2, or do they have to have a certain maturity level to even think of using your tools? Like, if they were only on 1, they'd be like, "I don't even know. Can't even conceive of using your tool." I mean, just where do you guys see your customers on on that continuum?
I
Yep.
would say that. Oh, okay,
You go.
yeah,
You go.
I'll go first. Yeah, it's a spectrum. I would say that like if someone isn't even bothering adopting cloud and has no like use cases on top of this and is like sort of, you know, 15 years behind, it's very difficult to kind of leapfrog that. Even with a
Yeah.
sufficiently, even if the technology is sufficiently disruptive, it's like, look, this is like not an early adopter, and some people only use it, which is fine. And you get some people on that. I would say that like,
So your
on
customer
the
like
other end
two
of
or
this,
three?
what's up? Yeah, like a two or three. I would say that like generally you need to have some degree of comfortability with like automation. You need for us at least, you need to have some degree of comfortability with cloud. And those would be the two main ones. And that's probably like, yeah, about a 3 out of 5 or so from an adoption perspective. Anything that's like less trustworthy than that, or is, has IP risks or something. I mean, IP is important, but has is like, okay, we can't use cloud, we can't exfiltrate anything, we can't touch behind a firewall. It's just challenging to adopt, something like an AI with, because, unless you're deploying something on premise, or just like, unless you're deploying something deeply within an embedded infrastructure network, ends up just being a challenge to kind of spin out to. So I would say 3 or above is good. If they're hosting their own LLMs, which many firms are now, that's great for like agent deployment. At least like some degree of comfortability on cloud, at least some degree of comfortability on automation is probably what we look for sort of the sweet spot of ideal customer adoption.
How about for your customers, Alyssa?
Nice. Yeah, it's similar. We because we work in manufacturing, we see a lot, like a big range, I would say. And we've actually been we came out very bullish on cloud, and we've had to adjust somewhat. And so in some cases we can be completely air gapped from the internet. But yeah, we do a lot of work in footwear. Footwear is interesting because it's a very traditional industry, and so a lot of the time, people are just like making physical things and testing them. And so this is a very early stage of digital adoption. Like, we can show them that actually they can do so much digitally, and it kind of is mind blowing. Typically, that's not the great fit though. Like, it's better when people are further along a digital adoption. But it's also exciting. It's honestly exciting to be helping some of these companies, digitize and move from 2 dimensions to 3 dimensions, where you get so much more information. Like, this is also a big unlock for a lot of people. I have not encountered any companies in the manufacturing space that are past like, I don't know, a 4, even a 3, maybe. It's more traditional.
Well, my thesis is that using software like Metafold or Cosmon kind of moves that bar, though. If a customer does take the risk and say, "Okay, I'm going to actually use these tools," is there sort of an epiphany? Have you seen an epiphany where the customer says, "Oh my God, if I didn't have all these data silos and my engineers actually talk to each other, they didn't hate each other, and different departments were communicating, and I didn't have data siloed in each department that couldn't talk to." Are you seeing the epiphanies where they're saying, "Wow, if we fix that, we'd be a better company and we'd actually make better products." And thank you, Metafold, and
Yes.
thank you, Cosmon, for bringing that epiphany to us.
Yeah, I love this because we have exactly seen this where people kind
That's
of
awesome.
begin to understand this opportunity and then start thinking bigger. Now, the challenge can be that you might have someone who latches onto this idea and like sees the vision, they see the future, they see what, the possible could be. It can be so difficult to get them, get the buy-in from the rest of the organization, depending on the scale and the structure. Yeah, it makes me really think about change management and how difficult that can be on an organizational scale when you're dealing with these large global enterprises. It's amazing,
Mm,
especially
that's
coming from a
awesome.
startup where you just like you move quickly, like so quickly, right? And then you enter these large organizations that just are so slow.
Rui, have you had
Yeah,
that same experience?
yeah, I would say similar. Usually this happens on the PLM side for us mostly. When you start thinking about information architecture, orchestration, and so on. I would say that this is something we've seen before. Of like, oh, hey, I want to go connect, especially because we're workflow orchestration. It's like, well, can I connect this to this, and then pull this thing out, and then like, oh, what if we could have better search over this version of our PLM or something like that? Is kind of where people start to put the pieces together on. It's interesting. I would say that like the big things are number one, yeah, the like cross-team coordination and looping in other departments is probably sometimes where that can get difficult. Within a team, within an organization, within certain parts of a PLM, this can be useful, but working across an entire global enterprise is slow. It takes a long time. Like there are the light bulb moments, but I still think even if there is internal conviction, there's still bureaucracy. There's still sort of pushing through on things, which becomes a challenge. That said, it's pretty clear this is where things are going. I think like better search, better information retrieval, better use cases of data and coordination of data between teams, and the ability to think about how to move that data between teams is the future of where engineering data management is going. How long it's going to take to get there, I don't know, but like pretty clear that like people are seeing this in a lot of fronts. Even I think across the list, and we have two pretty different products. Like people can start putting the light bulb on of like, oh hey, wait, what if I could digitize more? What if what if I could have a sort of better digital thread or so? And I think people kind of get turned on to that a bit.
We actually did have a question from Lisa Fenwick in the chat, and she asks, how is a company's IP protected when using these two tools, Cosmon and Metafold? What data sources are being used for the AI to operate on?
I can talk about this first. Yeah, so I mean, we run both cloud and air-gapped deployments depending on data sensitivity levels. So you can point basically we have like it's an agent, but like the agent can get deployed wherever. You just kind of need something to point it at as like a brain or like to drive it. We have our own models that like we can develop out and can get bolted onto a network. So you don't have to leave if you don't want to. Some people are okay with cloud, some people aren't okay with cloud. We try to be flexible to both. The second thing is, we don't upload or export the models or anything like that. We don't touch a lot of things. We touch a little bit of the metadata, really. We get audited, we get tested, stuff like that. But generally, what I would say is like we don't export the models. We don't touch a lot of the IP outside of like a lot of local processing on computer for these use cases. And the second thing is, if you're super sensitive, like if you're like, hey, cloud isn't okay, it doesn't really matter where the AI gets deployed. Like a cloud is just a computer. So if you have something on if you have something in your own network, if you have an intranet, if you have like the level of maturity where you can deploy that, you don't have to leak data at all. You can just kind of run everything behind a firewall. It's just about deploying an instance within the right network or right sort of local computer set.
Very cool. What about you, Lisa?
Yeah, we obviously take IP extremely seriously, and for manufacturers, their products are their IP, so this is very sensitive data. Because we don't have one model that we are operating on, there's never a sense that we're taking people's data and using it to improve or train a model. People can train their own models on their own data, and in fact, this is a huge source of potential competitive advantage for manufacturers who have a large corpus of historical product data. So we're always really excited to help people do this, but it's always just their data that they're operating on, and we're very careful to keep that that lives with them, not on our servers.
Understood. Well, actually, I'm kind of done with the questions already. That was kind of quick.
Amazing.
All right.
Yeah, no, it's great. Any parting thoughts from the two of you about AI, about your products, about where the market's going, where engineering's going?
I think it's too fast. I think you just got to stay on top of it. It's, I mean, as of today versus a year ago, it's a completely different world. Or forget 2 years ago, right? I would say that like parting thoughts on this are just, regardless of what you're doing, what you're working on, it's a disruptive technology. We don't know where it's going. Nobody knows where it's going. I think people can guess, but staying on top of it, making sure that it's front of mind is really important. And I think the best way to think about how to really deliver value, even if you're not sure right now, is just understand where it's getting, what's working. And then thinking about that for your own use cases and the analogies there is useful.
Nice. Yeah, agreed. And it's a interesting time, an exciting time. Hard to keep up, but like, yeah, I think there's so much opportunity and potential here that it's an interesting time to be building a company, and I think an interesting time to be adopting new technology as well. Our approach at Metafold is always to try to help people scale and kind of liberate and amplify their engineering expertise, not to replace it. And so I think that's that was the message I'd want to leave with on Metafold.
And if I permit another question, it seems too it's a very competitive landscape, right? Because I found in my database I have 500 startups in engineering software and industrial AI. It's astounding how many there are, and so it seems to you guys have both chosen a strategy of kind of picking one industry. You know, Rui, you're doing hardware, and Elisa, you said you were focusing primarily on footwear. Is that like a survival strategy, or is that just because it most interested you? Is that the way that you're able to carve a competitive moat because you're able to solve the problems very specifically to those industries? I'm just saying in terms of the strategy of how for other people that might be listening that thinking about, hey, I've got this great idea, but what do I do with it?
Yeah, for us, it's been important to pick a sharp focus. We don't just work in footwear. We have a few different industries we support, like electronics as well, and aerospace. But I think it's important to be very specialized and very sharp. And that's, yeah, it's a bit of a survival strategy in the sense of like, how do you begin? How do you enter a market and begin? And that's not really like a technical challenge. That's a business and go to market challenge.
Mm, interesting.
Yeah, I think it's a forcing function. I mean, you got 10-person team, something like that. Like you're not going to be able to take over the entire world of engineering. I mean, as much as you may like to, it's really just like, look, there's only some things you can do. You're really only going to get business if you do those things incredibly well or better than all alternatives. And so, like, you have to narrow your scope to be able to focus on, like, all right, we need to do like maybe two or three things max, like super well. That's it, right? And do that for years. And then if you get lucky and you get enough, you can kind of expand and specialize here. But definitely for a startup, focus is incredibly important. I wouldn't recommend doing more than like two things probably at a time. Even that's probably pushing it. I know some CEOs are like, look, just do one thing and do it extremely well. But that's kind of where we sort of balance here.
That's awesome. So it's only well, we're almost in March, but where can we see you guys in public? Where are you guys going to attend some conferences like the Threaded conference in Miami, for example? Where can people come and meet you guys and see your product live?
Yeah, so you can see not me, but my co-founder will probably be at Threaded. I'll be
No,
at
be it.
GTC.
Oh, cool.
So I'll be at GTC. I'll be out there. I'll be in a couple of other conferences across Silicon Valley, Simulation World, OZN, GTC, NAFEMS, and then also Threaded should be out there, and then a few in April as well. So a lot of the engineering events, conferences, you can probably find a rep from us there. Come say hi.
Nice.
How about
Yep.
you, Lisa?
Yeah, we tend to attend more manufacturing focused events. So we're doing one in Portland in a couple of
ITMS?
weeks. Yeah, we will be there. That's a little later, but more sooner we'll be at in Portland, and then also at Hanover Messe in
Oh,
April.
over here in
Yeah,
Germany. Nice.
yeah.
Very
I'm excited
cool.
for that. Yeah.
Are you going to go to CD Fam in Barca too?
Not planning to attend this year. I do love the CDFAM events. I've given plenty of talks at them, but not on the radar for this year.
So I'm thinking of going to the Barcelona one. I haven't
Oh,
met
you should
Durand yet,
go.
so I'm thinking,
Yes, they're great.
yeah,
They're great.
it's gonna be a lot of fun. Well, that's awesome, and yeah, I think it was a great conversation. I appreciate you guys both taking time out of your busy schedules, and I hope I get to meet you guys in person at some point during the year. So anyway, thank you very much. Thanks to the audience for tuning in, and I'll see you in the next AI across the product lifecycle podcast. Thank you, everybody.
Thanks for
Thanks.
having us.